Okay, let's start off by talking a little bit about award solutions. We have been in business for over 20 years. We are a very small company based out of Plano, Texas, just north of Dallas. And we specialize in doing a lot of training and instruction in the area of telecommunications. Um, Years ago, starting with 3G technologies, moving on through 4G, and now, of course, very much the focus on 5G. And some of our customers are the major wireless operators in the United States and indeed throughout the world. We are also a training partner of Mobile World Congress, and we participate in that event every year as well as CTIA and the rural carriers in the United States. We do have this is one of a series of webinars that we have coming up over the next several weeks. Today, of course, August 18th, we're talking about network slicing. And then just about a month from now, there will be a webinar on beamforming in 5G, and one on about a month after that on orchestration using Kubernetes, which of course is one of the key capabilities and functions provided when you're using containerized virtual machine technology. You can go to our website and find information on how to sign up for those webinars, and we'd love to see you there as well. And at the end of the session today, I will be providing you with a coupon that will give you some discounts on some of our upcoming training as well. Okay, just a couple of quick things. I think everybody is muted. If you're not muted, please stay muted if you're not talking. Helps keep the background noise down for everybody. Please do not take any copies of material by recording or any other means. Like I said, you will get a copy of the material I'm presenting today. And place your phones on silent mode if you could. This is me. I've been in the telecom industry for many, many years and been with Award Solutions for over 8 years. Currently, my focus is teaching and developing course materials in the area of 5G core, VoLTE, IMS, VoNR, voice solutions in 5G in general, and also previously LTE and network function virtualization. Okay, let us get into the material for today. So today, like I said, we're going to be going for an hour. I will finish off just before the hour's up to allow time for questions and some wrap up. But after the session today, you should be able to describe why we need network slicing in a 5G network. What are the motivations for it? And secondly, how the 5G networks helps to deliver different service types with varying degrees of performance requirements in the 5G network. And we'll also talk about how, from a device perspective or a subscriber perspective, how does that device assist in selecting the correct network slice for a particular, what is called a PDU session, and how does that match up with the information that's stored in the network as well. So let us start with the motivation for network slicing. Now, if you were to go back a few years before, when 5G was just being thought about, the ITU, International Telecommunications Union, recognized that one of the things they wanted 5G to be able to accommodate was a lot different type of usage scenarios compared to traditional networks. So while in 4G LTE, we have the ability to support pretty high data rates for many types of applications, today most of the traffic is pretty much internet type traffic or operators IMS network, or maybe virtual private networks. But with 5G, we're going to see a whole new range of services and applications and device types that will be able to make use of the wireless technology. And it's not a case of really one size fits all. So the ITU started by defining a number of usage scenarios that 5G should be able to accommodate. And the first of these usage scenarios is known as Enhanced Mobile Broadband, or EMBB. This would be typically for the types of services we do today, browsing the internet, streaming videos, and so forth, but offering much higher area traffic capacity and much higher peak data rates, as much as 20 gigabits per second, theoretically, in the downlink. The second usage scenario was one to accommodate a set of applications where we need both extra reliability and low latency. So this is known as URLLC, ultra reliable and low latency communications. And for example, in the RAN, the radio access network in 5G, we can support latencies that are less than 1 millisecond. And the third category was one to do with recognizing that there are many machine-to-machine type communications, or the massive Internet of Things devices, MIoT, where we may have a huge number of devices that need to be connected in a particular geographic area. So we need very high connection density. But these types of devices typically do not require very high data rates. The amount of data they send is actually very small and fairly infrequent. So those are the three usage scenarios that were defined initially by the ITU. Now, when 3GPP developed the specifications for 5G, they also adopted these three usage scenarios as what would become known as the three standardized network slices. And EMBB, URLLC, and MIoT are the first three standardized network slices that were adopted by the specifications. And then very recently, in release 16 of the 3GP specs, a fourth one was added, known as V2X, for vehicle to everything type communications. So at this point in time, we actually have 4 standardized slices that are defined by the 3GPP specifications. And in a little bit, we'll talk about what that means in terms of standardized versus non-standardized types of slices. So a bit of background on 5G and some of the capabilities it's expected to provide. So I previously mentioned peak data rates. Peak data rates in the downlink, theoretically, for 5G can be as high as 20 gigabits per second. Of course, that doesn't necessarily mean any one user will experience that because it's a shared medium. And in the uplink, as much as 10 gigabits per second. Latency. In 4G LTE, the fundamental air interface latency is 1 millisecond. Right? That's the interval at which we transmit data from device to base station or vice versa. In 5G, that number is less than 1 millisecond. Okay, so I talked about latency in the RAN. Connection density, being able to accommodate up to 1 million devices per square kilometer. Again, this is kind of that type capability that's more oriented towards the MIoT type devices. Cell throughput, from a perspective of network efficiency, at 10 megabits per second per square meter, and also to provide significantly improved cell edge data rates, right? So a minimum of 100 megabits, or rather a maximum of 100 megabits per second in the downlink at the cell edge and 50 megabits per second in the uplink. And again, if anyone does have questions, please feel free to use the chat or to ask me to unmute you. I don't see a way I can unmute anywhere, everybody. Okay, so what are some of the reasons why we would want to slice up the network? So think, if you would, for a moment about 4G LTE. Right? We have lots and lots of people that access the 4G network. You know, large operators have 100 million subscribers and so forth. And primarily what we're doing is, you know, three things: accessing the internet, web browsing, doing email, social media, streaming videos, those types of services. We're doing IMS services with the operators for things like VoLTE, for voice over IP calling. And we may be accessing some other types of services provided by the operator as well, or corporate VPN, or some specific applications that they have. And pretty much in that type of environment, we can say that how we want to classify the type of traffic we're talking about, it's generally high bandwidth, medium to high bandwidth type traffic with latencies that are not that important or that critical, except when it comes to things like voice. But if we think about those usage scenarios that we just saw defined by the ITU, some of those services and applications that 5G is intended to deliver need different capabilities. And what this means is a one-size-fits-all network may not be the optimum way to do things. What are the different types of services that we are looking at? Smart home, smart city, automation, self-driving cars, autonomous cars, connected cars, mission-critical type applications, different business applications, MVNO, business versus consumers with virtual private networks, being able to incorporate more third-party services as well as the operator services. So the solution to this is to say, if I have just one network, it is hard to, one, isolate and separate these different applications. And secondly, it is very hard to optimize the network to meet the needs of these different types of services that have very diverse performance requirements. So the answer is to slice up the network. We take the physical network and we slice it up into a number of virtual networks where we may dedicate or share resources. And then we can optimize each of those slices to meet the specific performance needs for the applications within those slices. So with a network slice, we're able to optimize the network, the virtual network, right? Still provide suitable end-to-end quality of service. We've got the now four standardized types that have been defined by 3GPP. And each of these network slices, right? The important thing to know about network slicing, it is definitely end-to-end. So network slicing requires two things. One, we must have an end-to-end 5G network ran through to core, known as option 2, standalone. And the second thing to note about network slicing is that we are slicing various parts of the network. So when we talk about a slice, we are going to slice up the RAN, the core network, the transport network, and also we can identify and provide specific management systems to manage within those slices independently. In the core network, we may allocate a specific set of network functions to a single slice, or we can share them across slices. So a network slice is a service-based logical networks using common shared hardware. So let's look at how network slicing is implemented and what it means. So here's an example of an operator defining 3 different network slices. At the very top here, we have the network slicing for mobile broadband or enhanced mobile broadband. Right? And we're going to slice up the RAN, we're going to slice up the core and the transport, and we'll provide specific management systems for that slice, because we can now manage these network functions independently within that one slice. And by managing network functions, what I'm talking about is to be able to decide how many instances we need of a particular network function to make sure we have the right capacity, to be able to dynamically adjust that if required based upon varying traffic needs, and to be able to offer and put in place the appropriate type of network function to meet the performance needs. Here's a network slice for vehicle-to-vehicle communications. Again, another slice of the RAN, different instances of various network functions to give us core slice 2 and independent management. And similarly for this last one here for MIoT, massive Internet of Things, a slice of the RAN and a slice of the core. Now, why is this important? And how do we go about slicing up the different things? So we'll talk about how we slice up the different things in just a little bit. But let's think about one particular aspect of this. And let's think about the core network. In the core network in 5G, we have a network function known as the UPF. It's the user plane function. It's the only network function in the core network that routes user traffic between the G node B, the RAN, and external data networks. Now, if I'm providing services for something like EMBB, I'm going to be dealing with extremely high amounts of data with, reasonably good requirements in terms of latency and stuff. So for the UPF, I would probably want to be able to provide one of the high-end, high-capacity, ultra-reliable type UPFs to serve those needs. So I'd probably be buying the most expensive UPF that the vendors like Cisco and Alu can offer. But when I get down to things like IoT, I don't need such high traffic rates. I don't particularly need very low latency. So there I could afford to put in place a much lower cost, lower performing type UPF to meet those requirements. So being able to separate the network functions in this manner to meet the requirements for a particular slice and its applications helps the operator put in place in the network the right capabilities to meet the diverse performance requirements. And let me just take a a few questions here. Yes, Srinath, the fourth slice is V to X, vehicle to X, means vehicle to everything type communications. There are a list of references, I believe, in the material. The basic place I would start in terms of specifications, Nilima, please start with 23501, 23502, and it will explain the concepts behind network slicing, and it will also lead you to some more detailed specifications that talk about network slicing management as well. What is the difference between SA and NSA? So when we talk about a standalone network, 5G defined many different deployment options, recognizing that the move from 4G to 5G is not a flash cut, it's going to be a gradual evolution. So standalone is kind of when we have, or standalone is when we have a full end-to-end 5G network, 5G RAN, 5G core, and we're not relying on LTE for anything. Between the LTE network and getting to full standalone, there are various other deployment options. One of the most common that operators have deployed today is known as option 3X, whereby we introduce the 5G RAN in places as an overlay onto the 4G network, but that 5G RAN still uses the 4G core. So it's not a full end-to-end 5G system. RAN resources are shared between these slices or dedicated. They can be shared, they can be dedicated, and that is an operator decision as to how they want to set up the slice. Vijendra, how will a single UE be able to access different slices? I think I'll be answering that question in a little bit, so let's hold on that one. If I haven't answered it before we get to the end, please let me know. Is it possible today? Two questions are very similar, having seen it deployed around the world yet. It is possible today if an operator has deployed the 5G core. And as many of you may know, today operators in terms of 5G deployment are at the stage of deploying option 3X, where there is no 5G core, with an expectation that 5G core will start to get deployed probably later this year and into next year. And they will gradually be able to transition to a full standalone 5G network. So today, yes, you would not see any network slicing in any commercial network, except maybe in a couple of instances where there are some small operators throughout the world that have deployed 5G standalone to start with. Okay. So what are some of the enablers within 5G that help deploy network slicing? So firstly, from a spectrum perspective, 5G has a lot wider range of spectrum available. Typically with third generation and fourth generation networks, we were operating in chunks of spectrum down anywhere from like 700, 800 megahertz up to 2.4 gigahertz, with mostly, certainly in LTE, 20 megahertz wide channels. 5G opens up spectrum in the mid-range and also the high frequency range known as millimeter wave radio. There is a lot more spectrum available there in those frequency bands, and secondly, because there's a lot more spectrum available, we can provide operators, or the FCC can allow operators to have much wider channel bandwidths. So if I've got more spectrum available, one of the things I can do is to say potentially chop up that spectrum and allocate certain pieces to specific network slices. In terms of user data, the subscription data in the UDM is updated to include network slicing information. So what actually happens in 5G, if you look at the subscription data, for any one subscriber, we allocate specific data networks, DNNs, data network names, to a specific slice. So this allocation is predefined in the subscriber profile. Software-defined networking and CUPS, control user plane separation, is yet another capability in the network, because by separating the user plane function from the control plane functions, we can scale those and manage them independently. Network function virtualization. The 5G core will be implemented on cloud computing platforms using network function virtualization techniques. This decoupling of hardware and software provides for a lot of scalability and flexibility to further support network slicing. And which leads into the next part about the next generation core network. We can now allocate functions specifically to slices, or we can share them between slices. And that's also true in part of the RAN with the split architecture with the G-Node B central unit. I've got a couple other questions here. Suzanne, I have not seen an announcement from T-Mobile on SA. I'll take a look for that. Do we need to be dividing the bandwidth in different parts for different use cases? That is one option, Vijendra. Unfortunately, the 3GPP specs do not say how to slice the RAM, but that is one option that operators could use. So the building blocks for the 5G network. On the radio interface itself, the NR, new radio, we have much more bandwidth available. We can do beamforming and MIMO. Those were available in 4G, but now we can do what's called massive beamforming and massive MIMO at the higher frequencies. We've got support across a whole range of frequencies from low through mid and high bands. 5G also introduces a flexible frame structure. And what that enables us to do is to have a variable time transmission interval. So we're no longer fixed at just a millisecond latency on the air interface. We can go down to quarter millisecond latency. The RAN itself supports a split architecture, the distributed unit and the central unit, different layers of the protocol stack. The G-Node B CU can be deployed more centrally to serve many, many DUs, and that CU will also be virtualized as well, which again means we can now start to make use of that for different network slices. In the core network, we've mentioned that the core network will be totally virtualized. That means we can have a lot of independent scaling and deploy many, many different instances of each of the network functions and allocate them to slices. And finally, edge computing. There's a relationship between network slicing and edge computing in that we can define the access to edge computing in a particular data network to be allocated to specific network slices as well. Horizontal and vertical. I think I don't use those terms myself, but I believe what they refer to in the industry is we think of vertical slicing as a type of slicing that serves specific industries. For example, an operator may choose to set up a slice for electric utilities or for banks, small banks or small businesses or something. Whereas horizontal is more about providing slices based upon different service types like EMBB, URLLC, V2X, and so forth. Is any MEC needed to reach latencies less than 1 millisecond? Okay, good question, Victor. Remember, 1 millisecond is just the fundamental air interface latency. When we look at the latency from a specific, for a specific application from a device through the network to the MEC application, that is typically going to be longer than 1 millisecond. But depending upon where we put the edge computing services, we can get latencies that are now in the 10 to, say, 50 millisecond range if we need to, one way from device to application. So Eve, that leads into your question. MEC is multi-access edge computing, and it's all about deploying applications on edge computing cloud platforms near the network edge or a lot closer to the network edge so that we can get reduced latencies and indeed get other advantages from doing that as well. Okay, let's think about this from a user perspective. What does the subscriber know about network slicing? Well, the subscriber really doesn't, because it's all hidden from him. So how do we manage network slices? Well, we're going to manage it all in the subscription profile for the user. So in that subscription profile, we will have slicing information for a subscriber. For example, we may have something that says slice equals EMBB. And within that, we may define or allocate a number of data network names, such as internet, such as IMS. Probably a very typical way that operators will set up that particular slice. So what that means is when that subscriber accesses those data networks, they are going to be within the EMBB slice. And then it's quite possible that we have another slice for this subscriber. Let's say it's company X. So this subscriber also has VPN access to a company network. And so we take the DNN, my company or something, and we would allocate it to that specific slice. And all of those accesses would be independent. Now, within each of those data networks, we still provide quality of service at the DNN and PDU session and QoS flow level, just like we would with LTE. And all of that would be defined within each DNN. So the user profile has all the slicing information. The device itself can also be configured with the slicing information. And the device uses this when we first access the network to tell the network, these are the slices I'd like to have access to. A DNN is the same concept of APN in 4G. Yes, that's correct. Now, Because devices can roam, and because not all slices may be available in all geographic areas in the network, when a device registers in 5G, the AMF is going to look at the requested slices from the device. It'll look at what's in the user profile, and it will know what's available in this particular registration area, in this particular PLMN. And it will identify a list of allowed slices for this particular access. And it may not match up with everything in the profile. For example, if this subscriber were to roam onto another network, they may not have access to this particular slice because it is operator specific. So the AMF determines the exact set of slices that would be available to the device in the specific registration area. A few terms for you. Network Slice Selection Assistance Information, or NSSAI. We are now at the stage of 5-letter acronyms, and they're really hard to pronounce. I hate this one, but what does it mean? Basically, it means which slice, right? Is it EMBB? Is it Company X? Is it IMS? Is it etc.? It's actually a list of slices, and there are many, many different NSSAIs. There's the configured ones, the requested ones, the allowed ones, and so forth. Within that list of network slice information is a single NSSAI that identifies one specific slice. And that one specific slice has an SST value, a slice service type, and in some cases, a slice differentiator. And an NSSAI is simply the SST value. And just so you know, EMBB is given the SST value of 1, URLLC is 2, MIOT is 3, and V2X is 4. So these are the standardized network slices defined in the specifications. Okay, so when we're using and accessing 5G, subscribers are going to set up PDU sessions to a data network. A PDU session is like a PDN connection in LTE. That PDU session, like this green line here, goes from the device through the G node B to the UPF and off to some external network. The role of the UPF is to route user traffic between the G node B and various data networks and enforce quality of service. So as we set up multiple PDU sessions, those PDU sessions will be set up in different network slices. Think of them as being allocated to network slices. And within the core network, each of those slices may have shared or dedicated resources. Now, within the 5G core, the network functions, a lot of the network functions have a key role to play in terms of how we access slices. So for example, the AMF, right, will serve multiple slices as well as doing authentication. It is also going to provide the UE, the device, with the allowed network slices during registration. There is a new capability in 5G known as the network slice selection function. And its role is to help the AMF figure out what network slices are allowed for a specific UE in the current registration area. Policy control function, like the PCRF in 4G, provides all the policy rules to the SMF, the session management function, that in turn configures those QoS rules into the UPF. The NRF is also a new capability in 5G. 5G uses something called the service-based architecture, and the NRF network functions register with the NRF, and network function services can then be discovered by other network functions using the NRF. So it's a somewhat different way of doing communications within the 5G core. Does different slices have separate UPFs? They can, they do not have to, right? Again, it's an operator decision as how they want to organize and set up the network. Does the UPF need to be deployed near to the RAN for low latency? It can be, and that's one of the advantages of the 5G architecture, in that there's a lot more flexibility in how to deploy UPFs and the number of them we can have. So any one subscriber could be served by many, many different UPFs for different PDU sessions. But also, we can also deploy those UPFs closer to the network edge so that we can serve the MEC applications. So yes, the answer is yes. They absolutely can be deployed much closer to the network edge together with the MEC apps. Okay, just taking a look here at the, give me 1 second here. I'm just doing a little time check for myself, see where we are. Yeah, okay. We're good. So I mentioned standardized and non-standardized slices, right? Standardized slices are defined by 3GPP, and of course we can now add in another one here, which is V2X, and it has the SST value of 4. SST is the slice service type. Now, the reason for the standardized slices is by standardizing them means devices can roam between operator networks and still have access to these slices, right? Assuming they're supported by the roaming partners in the visited network. But any operator can also define their own non-standard slices. And these non-standard slices, they wouldn't use SST1. They would probably be like 12, we'll make that one 14. Could be used to define different service levels, like broadband gold, broadband silver. They could be used for specific enterprise VPNs, so allocating a slice per VPN customer. They could be used for vertical industries like train companies, smart street lights within a city, etc., etc. Now, when an operator defines their own standardized slices, they can also define something called a slice differentiator. And the slice differentiator is just a sequence of characters and numbers, letters and numbers. And those are totally defined by the operator. And the reason for a slice differentiator is we may have, for example, smart streetlights as a slice, but we may have different sub-network slices of those differentiated by a slice differentiator. For example, city A, city B, city C, etc. Network slice can have multiple UPFs. Yes, Eswa, that's true. A network slice could have multiple UPFs to accommodate either multiple PDU sessions, and even within a PDU session, there could be multiple UPFs as well in some circumstances. Okay. Any other questions at this point? Why? The reason why we want to be able to deploy multiple UPFs is for flexibility. So I could say for a group of subscribers, they're going to access the internet through this UPF, but they'll access IMS services through a different one. Reasons of splitting out the traffic, reasons of putting in different types of UPFs to accommodate the specific service needs. Multiple UPFs per PDU session would be, for example, when we have both an edge UPF with that edge application and also a centralized one. So Vijaya, that's a great question, right? Because what you're getting to is how dynamic is this? So in theory, it can be very dynamic. It is quite possible for an operator. Remember, we're dealing with virtualized network functions. If during a particular time of day in an area, we find that traffic is very low on a particular slice, we could deallocate UPFs or SMFs or PCFs and allocate them somewhere else to another slice. So yes, it could be very dynamic. And remember, when we talk about network functions in 5G, it's not hardware, it's just software functions running on a cloud platform. All right, let me move on here. So in terms of the RAN, like I said, this is not standardized as to how the operators will split the RAN or indeed what the vendors will do. One option for RAN slicing is to do all this within the scheduler and have vendor proprietary algorithms. And I think that's one thing that will happen. Another option is for the operator to allocate specific bandwidth to a specific slice, so specific areas of the spectrum. So we may have a 100 megahertz channel allocated for EMBB, let's say at, at 700 or 700 megahertz, a combination of there, and maybe at 39 gigahertz, right? We'll put some spectrum for that. Whereas for V2X, where the data rates are not quite so high, we don't need as much bandwidth. Maybe we just allocate a small mini slot channel somewhere in the range of frequencies. Maybe that's at 2.4 gigahertz or something, or wherever. And similarly with IoT. So that is one way we can slice the RAN, right? Slice out specific areas of the spectrum or specific subcarriers. In the core is going to be deployed upon cloud platforms. Core network functions will simply be pieces of software, virtualized network functions running somewhere on a cloud platform. And that platform can be in a local data center, MITSO location, can be in an edge data center, can be in centralized data centers, right? So we can mix and match between all those different locations. And within each of those locations, we may have multiple racks of equipment. We almost certainly will, with multiple compute servers. And then we can go deploy on those the appropriate network functions we need and either allocate them to or share them across slices. So let's see, here's an example of where we have network functions here allocated to this particular slice, and we have some different ones here, and we could have some functions that are shared across slices as well. So there is complete flexibility from an operator perspective in how to set this up. You can certainly use multiple applications at the same time, absolutely. Remember, each application is just a PDU session, like a PDN connection in 4G. So we can absolutely have multiple. and they may be in the same slices or in different slices as determined by the subscription profile. Edge data center, cloud provider network. Yes, I see what you're getting at. Yes. An edge data center will still be operator provided. So these are all operator provided cloud platforms. Or server provider provided, yes. Okay, now in terms of the transport, it is possible to also split the transport up into different, allocate things to different slices. This can be done, excuse me, this can be done by dynamically defining different routes through, say, the backbone network. There is also right now a lot of interest in adopting something called segment routing. Segment routing splits the transport up into a number of small segments, and we link these segments together to define an end-to-end path. And we can then allocate specific segments to different network slices. Can one device use different slices for different applications? Yes, right? My email may be on eMBB. My high performance video streaming service could be on another type of slice. Yes, absolutely. The only constraint is that a PDU session is allocated, and a DNN is allocated to one specific slice and has to be solely within that slice. So we can't cross over slices, if you like. Yes, absolutely. Each UE will have multiple SSTs. Although in the initial deployment by operators, I think you'll find that they'll probably have one to start with, which is eMBB. All right, I'm getting close to the top of the hour here, and I do want to leave a little bit of time for questions. So just very quickly on management, we can have independent management systems that are managing each slice, i.e. managing all the resources within each slice and managing each service instances and mapping those into slices as well. Potential network slicing use cases, logical networks for the different service types like eMBB, URLLC, different service levels, bronze, silver, gold, service types, MIOT versus V2X. MVNO is another application for network slicing. Business versus consumer, and different market segments, addressing healthcare, utilities, factory automation, and so forth. Can an operator switch DNN? Not sure exactly what you mean by that question, Eswar. The DNN has to be totally contained within the slice. Okay, we are getting close to the top of the hour. So let me give a couple of minutes here for anyone to ask any other questions. Eswar, if I haven't answered your question, let me know. What the bandwidth part is related to network slicing? Not really, only to the extent that if we're setting up a network slice for a specific set of services, like eMBB, then we want to have sufficient bandwidth both on the RAN and through the core network through UPFs to be able to accommodate all the traffic we expect. Limitations related to frequency range? No, can be deployed in any spectrum. Any operator currently having 5G core deployed? I know of two. One, an operator in Kuwait deployed a full end-to-end 5G network last year. And I believe there's one somewhere in Southeast Asia. I think it's in South Korea. Can multiple slices be on the same frequency? Absolutely. Yes. Okay, please keep the questions coming. I just want to show you a couple of other things. There's a couple of QR codes here. Please follow us. You can follow Award Solutions on LinkedIn. I'm on LinkedIn if you'd like to join and follow me or link with me as well. I'm more than happy to do that. So please do that. And Manish is asking for the coupon. So here we go, Manish. There's 20% off all of our tech primers and self-paced e-learning. The coupon code is webinar. You can scan that QR code as well. So you just have to register between now and September 8th. That's all you need to do. Okay, we're at the top of the hour. Thank you very, very much for attending today. And I hope I was able to provide you with some good information. Thank you, Beverly, for the link. And please do contact us at any time. You can contact me. You can contact Award Solutions. We have a great website where you'll find some freebies as well. And also information about all of our training classes, including these complimentary webinars and everything else. Can I answer any more questions from anyone for today? The recording will be shared, yes. Okay, thank you for attending. Enjoyed it. Enjoy the rest of your day. Goodbye now.